All right, looking at quiz 4, go back to that SN1, SN2 type stuff, where that's where we're at this point. Give the type of reaction, mechanism, and product for each reaction below. For this one, so I think we hadn't learned E1 yet. E1 and SN1 kind of always compete. So if you only knew SN1 and SN2, this is for sure SN1, because this is not a reactive nucleophile, and this is a tertiary alkyl halide. So it has to be SN1. If you do an SN1 reaction, what's the first step? Or the rate determining step, leaving group leaves. You're going to form carbocations. And of course, you're worried about rearrangements for carbocations as well. But you're not worrying about stereochemistry because you can't do inversion. That's only an SN2 thing. So there's going to be more than one step. You're going to go through carbocation. And you're going to do a substitution, right? And usually the solvent is involved in the substitution. So in this case, first step, leaving group leaves. Carbon-bromine bond breaks, you make a carbocation. That's the slow step because you're making something without a full octet. Solvent reacts, lone pair. Again, notice the carbons don't leave, hydrogens are still there. Nucleophile reacts, we do a deprotonation. Deprotonation, right? Again, notice polar protic solvent. This is very similar to things we learned in Unit 3. Deprotonate, get HBr, and the new substituted product. All right, so the second one, So for the second one, it has similar to one below. However, it reacts at much slower rate. Give 2 reasons why and explain. So, right, we're assuming this is an SN1 reaction. So why would this set of conditions make this react slower? Secondary alkyl halide, right, makes it less stable carbocation, so that's going to slow it down. Oxygen is less nucleophilic than nitrogen just because of electronegativity, right? Oxygen holds its lone pair tighter, so it's a less reactive nucleophile. And also that's at a lower temp, right? So you need a lot of energy usually to form the carbocation. So that's going to make this slow step even slower. So I asked for 2, I showed 3. So again, this is kind of an SN1 versus SN2 type quiz. So why is one or the other? The rate doubles with 2 times the nucleophile. That has to be SN2 because the rate for SN2 involves the nucleophile. The rate for SN1 does not. A tertiary alkyl halide reacts faster than a secondary. This has to be SN1. SN2 reactions don't work with tertiary alkyl halides. Right? Some things you just got to kind of know about these things. The rate increases with an increase in the concentration of the electrophile. Both SN2's rate involves the electrophile, and so does the rate for SN1. So it could be either. Both could be going up. So it doesn't tell you which one. This doesn't help you determine either. So it's actually both. Right? So the rate for SN1 is rate constant times concentration of electrophile. SN2 is rate constant times concentration of electrophile and nucleophile. Right? So it could be both in this case. It's got to know those factors. So for number 4 here, it says for the SN2 reaction, notice it's bolded and underlined, right? So be looking for those things, read really carefully. So if it's an SN2, what do you know? SN2, you know it's one step. You know it's going to have inversion. If there's a stereocenter, it's going to take 2 arrows usually. So reactive small nucleophile here, good leaving group. Oxygen, lone pairs come, backside, break off that carbon-oxygen bond. This leaving group was wedged. That means the group you're adding has to be hatched. And there's your leaving group that's stable because of resonance. Lots of things you got to be able to see and do. Right? Recognize that SN1. For this one, what anion is a more reactive nucleophile? Why? Let's draw a picture. So again, this is just really a hybridization question. This one's more reactive because this has a lone pair in an sp3 hybrid orbital, which is farther from the positively charged nucleus. But I wanted to see you draw out, right, these orbitals. This lone pair is in an sp2 hybrid orbital, which is closer to the nucleus, so it's going to be less reactive because the nucleus has positively charged protons, which hold it tighter. So this is the more reactive nucleophile because of hybridization states.